Hello viewers, welcome to my channel. Today we shall be reviewing some of the works that we have for the JSS1 Students Mathematics second term. I still remain your mathematics teacher, Mr. Ndubisi Ephraim. Week 1 is the review of last term's work, resumption test and copying of the scheme of work for the term. Week 2 up until week 6, we shall be talking about algebra. In week 2, use of symbols, which is an aspect of algebra. We'll discuss about the open sentence, use of letters to represent symbols or shapes in open sentence. Week 3, still continuation of use of symbols, solving open sentence with two arithmetic operations. We'll also discuss word problems involving symbols. Then in week 4, still continuation of algebra, simplification of algebraic expression. We'll talk about the like and unlike terms in algebraic expression, identification of coefficient of terms in algebraic expression. Then week 5, simplification of algebraic expression, collection and simplification of like and unlike terms in algebraic expression. We'll also discuss use of brackets in algebra. Then week 6, simple equation. Then translation of word problems into equations and vice versa, solution of simple equations. Then week 7 will be the midterm, break and test. Then we move to week 8. Week 8 will be counting in base 2, that is binary numbers. Then we'll be discussing counting in group of twos, conversion of base 10 numerals to binary number, and binary number is the one we call base 2, and converting binary number to base 10 and vice versa. Now, week 9, we'll talk about the operation in basis, which is addition and subtraction of binary numbers. Week 10, multiplication of numbers in base 2. These are some of the works that we're going to be doing for the second term JSS1. Keep your fingers crossed as we delve into the topics proper. Please don't forget to click on the subscribe button as we continue to make mathematics easy and simple for you. Let's move to the next slide. Here is the first outline that we have for this particular episode. This is the aspect of algebra, use of symbols. First of all, what is an algebra? Algebra is the branch of mathematics that deals with the use of numbers and letters together. That is exactly what algebra is about. It's the combination, when you have a combination of letters and numbers, you call it an algebraic term. For example, you have something like this, 5x. 5x is an algebraic term because it is made up of a number and a letter put together. And that's why I said that algebra is the branch of mathematics that deals with the use of numbers and letters together. All right, so we are going to be looking at the questions that we have on the board. This is the first aspect of algebra that we'll be looking at, use of symbols. And the question simply put it, find the value in the box that makes the following statements true. What number enters in each of these boxes to make the statement true? This is a statement which says a certain number plus 3 will give 15. What is that certain number? And that is the missing link there. You are using the boxes in the form of symbols as we exemplified here. Symbols representing the boxes, or the boxes representing the symbols, as the case may be. All right, so what are the numbers that goes into these boxes to make these statements to be true? All right, so these equations, as we have already outlined here, represent what we call statements. We call them statements in mathematics. All right, so let's start with the first one. The first question says box plus 3 equal to 15. What enters this box to make the statement true, to produce 15? I believe somebody may have guessed what the answer is, or may have gotten the answer actually by counting, from 3 all the way to get into 15 to know the number that we added to 3 to get 15. Then another way we do that is this. We have to do it by collection of like terms. That means letting 3 move to the other side so that the box can stand on its own. Letting the box to stand on its own. This box can assume any kind of shape. It could be X, it could be Y, it could be any other thing. So, and that's what we call it symbols. All right, so look at what we're going to do here. We collect like terms. Collecting like terms means taking all the numbers to one side of the equality sign and letting the box stand on its own. 3 we move over to the other side of the equality sign. And one interesting thing about this is that when a number with a certain sign, say plus or minus, crosses the equal sign, that particular sign will change. For example, we have a plus 3 here. When plus 3 moves to the other side of the equality sign, this plus will turn out to become minus. That's exactly what we're talking about. If you have minus, when it crosses to the other side of the equality sign, the minus 8 will turn out to become plus 8. I hope it's quite clear. All right, so let's collect like terms as we have it here. That will now be box is equal to 15 is what we have here already. Then plus 3 going to the other side of the equality sign will change to become minus 3. So in this instance, our box will now be 15 minus 3. That will give us 12. So 12 is the number that goes into this box to make this particular statement to be true. So when we have 12 here, that will now be 12 plus 3. Will it give us 15? Of course, yes. So 12 plus 3 will give us 15. So the answer of this particular question is 12, because 12 is the number that goes into the box to make the statement true. We can use the same approach in solving number 2. Number 2, we have minus 8 here. When it goes to the other side, becomes what? Plus. So we have it as box is equal to 20, then minus 8 going to the other side become plus 8. So that will now give us box is equal to 20 plus 8 will give us 28. 28. So 28 is the number that goes into the box to make the statement true. All right, so we write it here, 28. So 28 minus 8, will it give us 20? Yes, of course, it will give us 20. Now let's move to number 3. Number 3 has to do with division. All right, so what we have here is 63 divided by a certain number will produce 7. What is that number that enters this box to make it true that 63 dividing the number will give us 7? Take, for example, we have 15 divided by 5. What will it give us? 3. Assuming we do not have this one given, as in the case of our question, we call it box. What do you think we will do to get this 5 that was originally here? We are going to get 5 there by saying 15 divided by 3. 15 divided by 3 will give us the 5 that we had here earlier on. So the same approach is what we're going to use here by saying 63 divided by 7 will give us the number that will be there. Let's do it with what we have. All right, so the solution will be 63 divided by 7 will give us the value of the box, and 63 divided by 7 will give us 9, because 9 times 7 will give us 63. So the number that goes into the box to make the statement true is 9. So 63 divided by 9 will give us 7, and that makes it a true statement. Let's move to number 4. Number 4, we have a 6 times or 6 multiply a certain number to give us 42. And what number is that? So let's use another example to show how we're going to approach this. If, for example, we have 2 times 3 to multiply 3 to give us 6. Assuming we do not have this, how do we get the 3 that was originally here? That is by saying 6 divided by 2 will give us the 3 that we had here. So the same approach we're going to use here, that would be 42 divided by 6 will give us the number that enters the box to make the statement true. Now let's look at it. That will then be 42 divided by 6. 42 divided by 6 will give us 7. So 7 is the result of the number that enters the box to make the statement true. That is to say, 6 times 7 will give us 42. And that's exactly how to approach this particular one. That's the use of symbols as an aspect of algebra. Now let's take a look at use of letters. Use of letters, we are going to be approaching it with substitution approach of the algebra. Let's get our fingers crossed. Please don't forget to click on the subscribe button as we continue to roll out the videos, and you'll be able to get the notification for other videos that will be coming up, because we're going to be treating all the topics of those in JSS1 as you have seen in the scheme of work. Let's get to the next one. Now let's talk about use of letters. In the use of letters, we are to do substitution. Here the question demands that we evaluate the following when the value of x is equal to 6. It could be any other alphabet. During exams, you might be presented with different kinds of alphabet, or maybe using letter M. You might be told that letter M is equal to so number, let's say equal to 18, equal to 9, and so on. But in this particular one, the question says evaluate the following when x is equal to 6. What it means is that wherever we see x in any of these expressions, we should replace it with 6. That is exactly what it means. Now let's get solution to this. The solution. All right, so the solution to this goes as follows. Number 1, we have x plus 9 plus x. Let's get the value. All right, so they said wherever we find x, we should put what? 6. So in place of this x, I put 6 plus 9 plus 6. What would the value be? 6 plus 9 will give us 15, and 15 plus 6 will give us 21. So 21 is the value of this. All right, so number 2. I hope this is clear enough. All right, so here we have a 5x. Some students, when asked this kind of question, to evaluate something like this, when the value of x is also a number, let's say 6, what they will do is that they will simply replace the x with 6 and say their answer is 56. No, it's not done that way. Looking at this particular example, 5x. 5x also means 5 times x. 5x means 5 times x. Because when you say 5 times x, that would still give us 5x. So it's in the form of multiplication, not in terms of just writing the number. All right, so that will not mean 5 multiplied by, in place of x, what do we write? 6. So in this instance, the answer becomes what? 30. So 30 is the answer to number 2. Okay. All right, so now we move to number 3. I hope this is clear enough. You can give number 3 a try. All right, so that is, pause the video and give number 3 a try. All right, so that will now be 30 minus, let's write it again, 2x plus 3x. So wherever we find x, we place what? 6 on it. So that becomes 30 minus 2. 2 multiplied, in place of x, what do we put there? That will be 6, because I said x is equal to 6. Then plus 3, in place of x, we still have 6 there. All right, so let's open the bracket. All right, so that will now mean 30 minus 2 times 6 will give us 12. Then plus 3 times 6 will give us 18. So how do we evaluate this? There are various ways through which we can do this and make the answer easy and simple. All right, that is by saying 30 minus 12 will give us 18. That will give us 18 plus 18. So what will be the answer? 36. So the result will be 36. Because 30 minus 12 will give us 18. Then plus 18. That will give us 36. Someone might say, let's use board mass. Yeah, board mass can actually give us the answer. Let me start with this. As we have 30 minus 12 plus 18. Someone might say you have to treat addition before you treat subtraction. So that's quite good. You can still do that. So that will now present us with 30 minus 12. This is not just 12, because somebody might say 12. Close your eyes on minus and say 12 plus 18. And the person will say 30. Of course, the answer becomes 0 in that instance. And that's wrong, because this is not just 12. This is minus 12. Don't ignore the sign. The sign is very, very crucial. All right, so for us to get that, that will have to be minus 12 plus 18. What will it give us? Minus 12 plus 18. What will it give us? So take minus as something you are owing somebody, then plus as what you have in your pocket. All right, so assuming you are owing someone 12 naira, or $12 or 12 cents, as the case may be, plus 18, and you have 18 with you. That is to say, when you pay the person the 12 you are owing, you will no longer be owing anymore. You will have something left with you. You have a change. All right, so minus 12, you are owing 12, plus 18, you have 18. When you pay, you will have 6 left in your pocket. That will now be plus 6 in that instance. So when you now say 30 plus 6 will still give us 36. So whichever method that is easier for you, you make use of it. And this is exactly what we have to give you in the aspect of use of letters as an aspect of algebra. All right, so let's move to the next one. Coefficient of algebraic terms. Here we're to talk about the coefficient of algebraic terms. What do we mean by this coefficient of algebraic terms? Take for example, you have 8 multiply m. What do you have? 8 times m will give us 8m. So the coefficient of m is the number that multiplies m to get 8m. And what number is that? 8. So the number or the letter that multiplies a certain number or alphabet to get the product is the coefficient of one another. In this case now, 8 times m will give us 8m. The coefficient of m is 8. I can put it this way, the coefficient of 8 is m. So it has to be a product. It has to be a product whereby each of the alphabet or number represent the coefficient of one another. In this case now, coefficient of m is 8. Coefficient of 8 is m. But in this example that we are being given, the question says identify the coefficients of either x or y in the following. So let's get our attention towards x and y that has to do with these expressions. Let's start with the first one. The first one seems very simple, going by my explanation. 4y. What is the coefficient of y here? The coefficient of y is the number that multiplies y to give us this product. So the coefficient of y here is 4. 4 is the coefficient of y. Because if I say 4 times y, that will give me 4y. So the coefficient of y is 4. Had it been the asked, what is the coefficient of 4? I would have said y. Alright, so the coefficient of y is 4. So 4 is the answer to this particular one. Then number 2, you can see it's quite easy. Number 2, we have 3y over 4. So what is the coefficient of y here? There is another way I can represent this fraction. I can represent this fraction this way and it will still mean the same thing. That is 3 over 4 multiplied by y. Will it give us the same thing? Will it give the same result? Of course, yes, because when I say 3 times y will give me 3y. 4 times 1 will give me 4. So the coefficients of this y here is the number that is attached to y by multiplication, and that number is 3 over 4. So the answer to this particular one is 3 over 4. That is the coefficients of y. Some students will simply say the coefficients of y is 3, ignoring the one that you have in the denominator. No, you don't do that. Because when you say y multiply 3 over 4 will still give us the whole thing that we have here. So therefore, the coefficients of y here is 3 over 4. Now let's take a look at number 3. Question number 3, we have x over 5. I can still write x over 5 as 1 over 5 multiplied by x. They are the same thing. They are the same because this x here, the coefficients of x here is 1 because there is one invisible one that is attached to x here. So therefore, we can liken it as 1 over 5. That means there is an invisible number here in the form of 1 that we can see. It's just like somebody saying we have this as a cup. We have another cup. All right, so how many cups do we have? Somebody can say 2 cups. Someone can say 2 cups. So we have 2 cups here. If I ask you, how many cups do we have? You will say 2. Okay, you say 2 because this number of cups represents the coefficient that we are talking about. All right, so in the case of this one, if I ask you how many x do I have here, you say 1x. All right, so but in algebra, we don't write it like this, 1x. We don't write it like this, 1x. But now, in this particular one, we have a number that is written other than 1. But when you have a number that is just single number, you don't have to write 1x. Because we know that that 1 is existing there, but it is what? Invisible. All right, so let's take a look at what the answer will now be. I believe you can guess what the answer is there. So 1 over 5 multiply x will give us 1 times x, x. 5 times 1 will give us 5. So the coefficient of this x will be 1 over 5. It's just like asking, if I have something like this, y over 7, can you guess what the answer will be? Of course, the coefficients of y here will be 1 over 7. Hope it's clear enough. All right, so let's move to number 4. Question number 4. In number 4, we have 20x minus 10. What is the coefficient of x in this particular one? The coefficient of x here is the number that is attached to x by multiplication. When you look at the 10 that we have here, this 10 has no x attached to it. So therefore, 10 minus 10, as the case may be, is none of our business as far as this question is concerned. We only concentrate to the one with x in it because the question says the coefficients of either x or y. So this is the only place we have x. So we are concentrating on the number that is attached to x. This one has no x. Assuming we have the question like this, 20x minus 10x. That's when it will now include 10. So both of them becomes like term. I can now say 20x minus 10x will give us what? 10x. So in this instance, if I now ask what is the coefficient of x, the answer will be 10. But for this particular one here, we can't assume that 10 has x in it because it clearly does not have x. All right, so we are concentrating towards the one that is attached with x, and that number is what? 20. So the answer to this is what? 20. That is the coefficient of x in this particular instance. The reason being that this 10 has no x in it, so you cannot evaluate both of them together because they are unlike terms. Number 5. Number 5, we have 4 minus 8x. What is the coefficient of x in this particular example? The coefficient of x here will be the number that is attached to x by multiplication as a product. This 4 has no x in it. So therefore, we are concentrating to the number where x is attached to. And that number is what? Can you guess what the number is? I know somebody may have said 8. This is not 8. This is minus 8. Remember, in algebra, those signs are very, very crucial. When you see minus, you must identify it. So what we have here is minus 8, not just 8. To every number, there is always a sign attached to it. Like 4 that we have here, no sign is written here, but we know that it's a plus. When there is no sign, that number is assumed to be a positive number. All right, so the plus becomes invisible. But in the case of this one, minus is written clearly. So the coefficient of x is what? Minus 8. Minus 8. So that is the answer to the 5th question there. I hope this is quite clear enough. All right, so let's get the coefficients of number 6 and number 7. For number 6, here we have y plus 4y. In this particular example, both of them are like terms. They contain the same alphabet, so we can bring them together. So 1y plus 4y will give us 5y. So can we now suggest what the coefficient of y is? The coefficient of y in this instance is what? 5. Unlike numbers 5 and number 4, that's the other part of the expression does not contain the same letter. This one both sides of the expression contains the same letter, and that's why we can bring them together. We can't say 20x minus 10. It does not make sense unless you have x attached to the other number. So that's when you can say both of them are alike. That means they look alike. They are putting on the same shirt. Here, this one is putting 20x, 20x. This one is just 10. It has no x in it, so we cannot bring them together because they don't belong to the same family. All right, so the coefficients of x here, the reason why we evaluated this one together is because both of them contain y. This is 1y plus 4y. That will give us 5y. The coefficients of y will now give us 5. So for number 7 is quite easy. Number 7 is quite easy. All right, so look at what we're going to do. X here, somebody can suggest what the answer is. No number is attached to x here, but we know that there is an invisible number there. And what invisible number do we have attached to this x? All right, so the number is 1. So the coefficients of x in this case is 1. So 1 is the answer. I hope this is quite clear about coefficient of algebraic terms. All right, so we'll be taking questions in the aspect of simple equations using the concept of coefficient of terms to now show you how to identify them in a particular question. I hope this is quite clear. All right, so you can watch it over and over again before you'll be able to take our test or assignment that will be given. Ensure you do this assignment in your rough book, and that will be presented at the beginning of the second term. Let's go to the next one. Here we have open sentence, in other words, simple equations. All right, so let's have a look at this particular section. Open sentence. When you hear open sentence, it has to be with something that has to do with balancing. Open sentence has to do with balancing. Now look at it here. If, for example, you have a swing like this. Let's say you have a swing. In that swing, one person is here sitting on this tray. Another person is sitting on this one. Okay, so this is something that children normally use in playing in primary school. All right, so assuming somebody that weighs 10 kg is sitting on this particular tray here, then another person that is weighing 8 kg is sitting on this one. What do you think will happen? What will happen to this particular swing? I know somebody may have gotten the answer because this one has more weight than the other one. So it will tend to bend this way. This one will go down while this one will be lifted up. What do you do to make sure that both of them have a balance? How do we ensure that both of them have a balance in such a way that it will neither go this way nor the other way? What happens? I know somebody may have gotten the answer. What you have to do is to add 2 kg to this particular person, so that this one will not be 10 kg, this one will be 10 kg, so it will balance. It will neither go this way nor the other way. So the number needed for it to gain balance is 2 kg. And that is the aspect of open sentence we are talking about. This is an equation. The equal sign here represents the fulcrum that we have here, which tells us the number at the right hand side and number at the left hand side. What makes both of them to be equal in such a way that it will neither go this way nor the other way. In the number one question now, what number do we put here so that when we say that number plus 6 will give all the same thing we have here, so that it can gain a balance without either going this way nor the other way around, just like the way we have exemplified it in this particular example. All right, so that's exactly the concept that we are going to be employing in this open sentence and simple equations. Now let's get started with some of these examples. All right, so let's start with the first one. Example 1, solutions. In number 1, we have x plus 6 equal to 20. So how do we solve this? We solve this by collecting like terms. So we let all the numbers move to one side and let the alphabet be at one side. Or better still, someone can say subtract the number you have towards that x, because we want x to stand alone. You subtract, since you have plus 6 here, you subtract 6 from both sides. And when that is done, then you'll be able to have x standing on its own. And that will give you the answer. That will gain a balance of this particular equation that we have here. All right, so we collect like term by letting number meeting the other number at one side of the equality sign. This equal sign here represents the center. It represents the center. So this number we have to leave so that x can stand alone. So remember what I said earlier on, that when positive leaves the equal sign, move to the other side of the equal sign, the sign will change to minus. If it's minus that is here, when it goes to the other side, it becomes what? Plus, as the case may be. Now, let's take a look at this. That will now be x is equal to 20. Then plus 6 going to the other side become minus 6. Then x will now simply give us 20 minus 6 will give us 14. So 14 is the number that goes into this place. That if I put 14 here, I can simply say 20 is here. Then 14 plus 6 is what? 20. So it can balance. It will neither go this way nor the other way. And that's exactly what open sentence is all about. Then number 2, using similar approach, we have a x minus 6 is equal to 20. So how do we address this one? We collect like term by letting minus 6 move to the other side. We have it as x is equal to 20. When minus 6 crosses the other side, what does it become? Plus 6. Then x will now be equal to 26. So 26 is the number that goes into this. So that when we say 26 minus 6 will give us the same thing as 20. So it will neither go this way nor the other way. So that's exactly what we are talking about. I hope this number 1 and number 2 is quite clear enough so that we can erase it and move to the next example. Have you taken note of the number 1 and number 2? All right, so let's now move to number 3. Let's move to number 3. Please don't forget to click on the subscribe button so that you'll be able to get other subsequent videos as they come online. You'll be able to get the notification, but if you did not subscribe, you may not be able to get the notification of the new videos that will be coming up, because we will treat all the topics that are contained in the scheme of work for the JSS1 second term. All right, so number 3, here we have 3y, that's 3y is equal to 21. All right, so when we are being challenged with something like this, a situation whereby you have an algebraic term here in the name of 3y equal to you have a single number, there's something we are going to do in order to eliminate this 3 from y so that y can stand alone. What do we do in this instance? What we do is that we divide both sides by the coefficient of y. Now the question is, what is the coefficient of y in this particular example? What's the coefficient of y? We have done coefficient. The coefficient of y is what? 3. So you divide both sides by the coefficient of y. And the coefficient of y is 3. So you are going to use 3 to divide the side, and also use 3 to divide the side. And look at how we'll be doing it. That will be 3y over 3. Because they say we should use the coefficient of y to divide both sides. The coefficient of y is 3. We use it to divide this side, then 21, we equally use it to divide this side. Then 3, we cancel out 3. Y will now be equal to 21 divided by 3, will give us 7. So 7 becomes the answer. So that when I say 3 times y is 3y, so 3 times 7 in place of y will give us 21. That will give us another balancing, that it will neither go this way nor the other way. All right, so now let's take a look at number 4. I hope this is quite clear enough. Take note of it. All right, so you can give number 4 a try. Now let's move to number 4 question. Question 4. Let's have a look at question 4. Question number 4 says 14 plus n equal to 37. So we collect like term by letting the number here, because this is equal sign, we have the right hand side, the left hand side. So the 14 we have to leave here. What sign is 14 carrying? What sign does it possess? 14 possesses plus sign. There's a plus here, but it's invisible. So we collect light time by letting it move to the other side. So we have 37 at the right hand side already. Then plus 14 moving to this side becomes what? Minus 14. All right, so M will give us 37 minus 14. So this gives us 3. This gives us 2. So the answer to the question is 23. So now when we say 14 plus 23, it will give us 37, I mean to say. All right, so that becomes the answer to the question. So number 5, let's have a look at number 5. Number 5 will have 6k is equal to 15 plus k. All right, so the first thing we have to do here is to collect like terms. That is by letting k move to his elder brother here, 6k. So this is a smaller k. I'll bring it over to this side so that 15 will stand alone. All the things that has to do with k will move to one side. All right, so here I have 6k. Then plus k coming here becomes minus k equal to 15. What do we do next? We subtract this because they are like terms. They have the same alphabet. 6k minus 1k will give us what? 5k equal to 15. So what do we do next? Similar to what we did to number 3, we divide both sides by the coefficient of k. The coefficient of k is 5. So we use 5 to divide both sides. We say over 5, 15 over 5. That is what we're to do. Then 5 cancel 5. K will be equal to 15 divided by 5 will give us 3. So the answer to this, K is equal to 3. So that is the solution to number 5, number 4 and number 5. I hope you have taken note of this as we move to number 6 and number 7. You can give number 6 a try, can you? All right, so let's move to that. Question 7. For 6 first, before we go to 7. Question 6 says 2x plus 3 equal to 3x plus 15. So now we have two like terms each here. Here we have a 2x. At the other side we also have 3x. Here we have a number. At the other side we have a number. So we have the right hand side and the left hand side. So by so doing, we are going to get all the x at one position and all the numbers at one position. So I would suggest that when you look at the alphabets as we have it, 2x and 3x, to make it easier for you, take the smaller alphabet to the bigger one. Then for the numbers, you can take any one anywhere you want to take it. All right, so that is to say, I will take 2x to this other side. Then I'll have to now bring 15 back to his brother right here, so that we're able to collect like that in such a way that we have all the same alphabet one side and have the numbers at one side. So this, as the smaller one, will move over to the other side. So that does not mean that if you bring 3x to this side that you will not get the same answer. You get the same answer. The most important thing is for you to take all the signs, all the like terms to one place. And while doing that, must be very careful with the sign. Remember what we said, when plus move to the other side becomes minus. When minus move to the other place, it becomes plus, as the case may be. All right, so let's now take 2x to the other side and bring 15 to this other side, so that 15 and 3 will be this side, then 2x and 3x will be at the same side. The reason why I'm doing it this way is because this one is bigger than this one. I want to take it to this side so that it will not be much difficult for you to do the calculation. Now look at what I'm going to do now. That one, I have 3 here already. Then 15 coming here is plus 15. When it comes to this side, become minus 15. I already have 3x here. 2x plus 2x coming here will come minus 2x. All right, so let's now conclude. 3 minus 15. Who can tell me what the answer is? Because if we have 15 minus 3, that will give us 12, right? Okay, because a bigger number minus smaller number will give us positive number. That's what we call positive difference. But when a small number like 3 minus 15, what will it give us? It will give us minus 12. That is called negative difference because a smaller number is subtracting a bigger number. In that instance, it's going to give you a negative of the answer. All right, so looking at this one, 3 minus 15 will give us minus 12 equal to 3x minus 2x will leave us with only 1x. So therefore, we can say that x is equal to minus 12. That is the answer to this particular one. All right, so take note of it. Now we move to number 7, which is the last question that we have here. So number 7, we have 4x plus 3 is equal to 20. All right, so we collect like term by letting 3 move to the other side. We have it as 4x is equal to 20. Okay. Plus 3 moving to the other side become minus 3. So we have it as 4x. 20 minus 3 will give us 17. So what do we do next? We divide both sides by the coefficient of x. What's the coefficient of x here? 4. We use 4 to divide both sides. 4x over 4 then equal to 17 over 4. So that's exactly what we have there. Then 4, we cancel out 4. Then what do we have? X will now be equal to 17 over 4. Or that will become 4 whole number 1 over 4. That is the answer to this particular one. All right, so this is where we're going to draw the curtain for today. So you get your assignment now. Now make sure you do this assignment. In our next video, we'll be giving you solutions to all the assignment that will be given to you right now. All right, so make sure you do the assignments and it's to keep yourself busy in this particular holiday. Thank you and have a great day ahead. Here is your assignment. Number 1, find the value in the box that makes these following statements true. You can say box minus 7 equal to 17. B, box divided by 9 equal to 6. Then number 2, evaluate 5x plus 3x when x equal to 4. Number 3, identify the coefficients of x or y in the following. Here, number A, you have a 5x. Number B, you have 5y over 7. Number C, you have a 9x minus 6. And number D, you have x over 3. Then number 4, solve the following, where you have 4y as number A, 4y equal to 20. Number B, 2x minus 3 equal to 7. Number C, m minus 19 equal to 13 minus 3m. So give this a try, solve it in your rough book, and get ready for the next video, where we'll give the answers to all these questions. Have a great day ahead. Bye.